ASDIP WOOD is a software for the design of wood members and components. The package includes the design of wood beams, but how do you actually enter the information in the program? How do you check the results? How do you optimize the design? This is Javier Encinas, and today we're going to design completely from scratch a Glulam beam as shown here, showing all these aspects of the software. So let's get started. This is a simply supported Glulam beam, 48 feet span. It has a uniform load. Dead load is 250 pounds per foot. Snow load is 750 pounds per foot. The Glulam stress class is 24F 1.8E Douglas fir. It's in dry conditions and under normal temperature. So the goal is to design the beam for the following conditions. First, we will assume that the beam is laterally braced at 8 feet spacing, and then the beam is laterally braced at the supports only. So we will design the beam for these two conditions. Let's go to ASDIP WOOD. When you open ASDIP WOOD, you see the project manager, where you can see the modules included in the package: wood column, wood beam, and wood bearing wall. In this example, we're going to design a wood beam. So let's create a calculation for a wood beam. Let's call the calculations Glulam brace at 8 feet spacing. Add, and the calculation has been added to the tree. Let's double click on the node. And this is the template of the wood beam design in ASDIP WOOD. Here at the top, in the Geometry tab, we select the type of beam. In this case, it's going to be a Glulam beam. The species region is going to be Western species. If we click on this button, we can select the section from the database. This is the table 1C from the NDS. We will come back later to select the section here. Here at the bottom, we specify the spans. So the beam is supported on 2 supports, so single span. The span length is 48 feet. Pin at the ends. We go to the lateral bracing. Here we specify that the beam is braced at the top at spacing of 8 feet. If we go to the Materials tab, here we can select the material according to the statement of the problem. Select from database. This is the table 5A from the NDS supplement. Here we're going to select 24F before the FDF, so Douglas fir. This is the material that we're going to use in this example. After the selection, ASDIP WOOD shows here the reference design values. At the bottom, from the statement of the problem, the beam is under dry conditions, so 0%, and under normal temperature conditions. We go to the Loads tab. Here we enter the information given in the statement of the problem. We have a uniform load. Dead load is 250 pounds per foot, and snow load is 750 pounds per foot. Please note that the units are PSF, so it needs to be multiplied by a tributary width. In this case, we're going to specify tributary width of 1, so this is 150 PLF, and it's going to be applied in the full length of the span. Graphically, we can see the beam here. This is the shear diagram, and this is the moment diagram. Of course, the controlling load combination is going to be dead plus snow. So these are the conditions for shear, for bending, also showing the reactions and the controlling load combination. Please note that we are designing per ASD. Up to this point, we have completed all the information given in the statement of the problem. Go to our Glance tab. Of course, we have several deficiencies here because we haven't designed the beam yet. We go to the Geometry tab again. Here we can select now the size that can meet the requirements. Select from database, scroll down. Let's say that we specify a section 6 3/4 per 21. It's just a first trial. Select. Here we can see that section is still failing in bending, also is failing in deflection. So we need to use a deeper section just to pass all these requirements. Go to the database again. Let's select now 6.75 times 30 to see if we are closer. It's still failing by 58%. Also the deflections are failing. So we need to use a deeper section. Let's use 675 by 36. Still failing by 13%. Also the deflections are failing here. So we need a deeper section to that. Let's say 675 by 39. Select. And finally this section is passing. The bending ratio is 0.98 and the shear ratio is 0.41. Also in the deflections this is passing, 0.93. In the long term is failing by 1%, so it's acceptable. If we go to the Condense tab, we can see a more detailed set of calculations grouped by topic. These are the support reactions per load combination, shear forces compared to the shear strength, so everything is passing in this section. These are the bending moments per load combination. These moments are compared to the bending strength. All these moments are passing as well. This is the section of the maximum deflections. And finally the bearing calculations also passing. If we go to the Detail tab, the Detail tab shows a detailed set of calculations, step by step. These are the reference design values, the calculated adjustment factors for the load combination depth plus snow. For this combination, the duration factor CD is 1.15. Then the volume factor is calculated at 0.80. And finally, the stability factor CL is 0.97. Here we see the adjusted design values. Please note that for bending, the controlling factor is CB over CL, is 0.80 over 0.98. Then the adjusted shear stress and the adjusted modulus of elasticity. Here at the bottom we see the calculations for bending. So the maximum moment is 306 and the positive bending strength is 313. So it's passing. The shear calculations, the maximum shear is 21.8 and the positive shear strength is 53.5. So it's passing. Bearing calculations are passing as well. Maximum reaction is 25.5 and the bearing strength is 35.5. This is the calculation of the deflections, so everything is passing. For the long-term deflection is not passing by a very small margin. So this is the final design for this condition of laterally supported at 8 feet spacing. The beam size is 6.75 by 39 inches. Let's go back to the project manager. To evaluate the second condition, let's clone this calculation. This time is going to be called Glulam braced at supports only. Let's click on this second calculation. This is a clone of the first calculation, so it's exactly the same. What we're going to change here is lateral bracing. Instead of 8 feet, we're going to select braced as support only. Obviously, the section that we picked before is not passing here. It is overstressed by 77%. So we need to select another section from the database. Let's say that we select the maximum 675 by 60. It's a very deep section, but it's still not passing. It's 23% over. So we need to select a wider section. Instead of 675, let's say 875. Let's try 875 by 24. It's not passing by 92%. Let's select a deeper section. Let's say by 33. It's over by 8%. Let's go back and select a deeper section. 875 by 36. This section is passing. Also here in the deflections, the section is passing except for the long term. It's over by 1%, so it's acceptable as it is. Go to the Detail tab, braced at supports only, reference design values, here the adjustment factors, and this is the adjusted design values. Please note that the adjusted bending stress is controlled now by CL, which is the stability factor, 0.74, over CV, which is 0.78. This is the bending calculations, again, with the maximum bending and the maximum strength, so the section is passing. The shear calculations, this is the maximum shear versus the positive shear strength, so the section is passing. Bearing calculations, maximum reaction versus bearing strength, section is passing. And finally, the deflection calculations. So this is the final calculation for this condition of beam laterally braced at supports only. The section is 8.75 by 36 inches. As you can see, it's very easy to design a Glulam beam using ASDIP wood. We were able to design this member in just a few minutes, that otherwise would take much longer if we try to design it by hand. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.